A tutorial for drawing Bohr-style electron diagrams by Misty. Write the full name of the element at the top center of your diagram. In this example, we're going to use the element neon. Write the atomic number to the left of the element's name. On this periodic table, you'll see that the atomic number is actually more prominent than any other piece of information in the periodic table box for neon. In this case, the atomic number for neon would be 10. Write the rounded atomic mass to the right of the element's name. Look on the periodic table to get this information as well. Look at the actual atomic mass and round to the nearest whole number. 20.18 would be rounded to 20. 20 AMUs, 20 atomic mass units. Use the information in your heading to calculate the number of protons and neutrons in the nucleus. The number of protons is easy. That's the same as the atomic number. The number of neutrons is a little bit harder. You have to work for that one. Round the atomic mass and subtract the atomic number. In this case, it would be 20 minus 10, which gives you 10. So in neon, you would actually find 10 protons, 10 neutrons, and 10 electrons. Look at the periodic table and record the correct electron configuration for the atom at the bottom of the diagram. The electron configuration is going to simply tell you where you will find the electrons in this particular atom. Start on the right-hand side and copy the electron configuration from right to left, recording the first thing, or the last thing, that you see, 2p6. This means on the second energy level, p subshell, you'll find 6 electrons. Then take a step back and record the information just to the left of that, 2s2, which means second energy level, s subshell, you'll find 2 electrons. Then you'll notice a reference to the element helium. This means the periodic table is simply out of space, and they need to send you back to helium to record the last piece of information for this atom. If you go back to the box for helium, you'll see that the electron configuration for helium is 1s2. First energy level, S subshell, you'll find 2 electrons. So the complete electron configuration for this atom would read 1s2, 2s2, 2p6. Draw the energy levels, including subshells, for your diagram. You would simply look at the electron configuration and draw all of the main energy levels used in that particular atom. In this particular atom, you'll find electrons in the first and second main energy levels, so you would need to draw both, and all of the subshells contained within. Plot your electrons. Simply reading the electron configuration, you can determine how many electrons should fall on each of these individual energy levels. 1s should contain 2 electrons, 2s should contain 2 electrons, and 2p will have 6 electrons. Notice that the electrons are spaced evenly apart. This is because electrons are negatively charged and would likely repel each other, so you don't want to place all of your electrons right next to each other on the same level. Check your work and create a summary chart of each subshell's contents in the upper right-hand corner of your diagram. This will give you a chance to check your work. By adding the number of electrons, you can make sure that you've done your diagram correctly. In this particular atom, neon, we said earlier that we would need 10 protons, 10 neutrons, and 10 electrons. By doing a summary chart, you can make sure that you've accounted for all of them. Thanks for watching.